So let's continue with the Unit 1 walkthrough. This is question 4. These will also come from section 7.2, solving equations. So again, we want to solve this equation for x. Again, the steps for solving equations, we want to simplify each side of the equation, removing parentheses or combined like terms. So I do see that the left side, there's not any parentheses, and the 7x and the 5 are not like terms. However, on the right side, I can remove the parentheses using the distributive property. So we do want to multiply this 7 through the parentheses over here. So I'll go ahead and just bring down the left side of the equation, 7x plus 5. Then I'm going to go ahead and move the 7 through the parentheses. I want to multiply it through the parentheses. So 7 times x is going to be 7x. And 7 times negative 5 is going to be a negative 35. So now 7x minus 35 are not like terms. So the next step is, if the variable's on both sides, pick on the little guy using the zero pair. Well, if I look at this equation, x is on both sides of the equation, but there's actually not a little guy. So this is already looking a little suspicious. So what we go ahead and do is just zero out the 7x. So to zero that out, we want to subtract the 7x here as long as we subtract the 7x over here. So what happens is the 7x and negative 7x are going to zero out, so the variable is disappearing. 7x and negative 7x is zeroed out, so we're left with the negative 35 there. So we actually can't solve for x at this point because the x fell out of the problem. So this drops us all the way down to step 5. When the variable drops out of the equation, if the remaining equation is true, then the solution is all real numbers. If the remaining equation is false, then the solution is no solution. What we came up with is 5 equals negative 35. Well, that's a false statement. So that means there's actually no solution to this equation. So there's no value of x that can make this actually true. So there's no solution. So if I look at this example here, we have 8x minus 12 plus 6x equals then 4 times the quantity, 6x minus 5 plus 6. On the left side, I'm seeing that the 8x and the 6 are like terms, so I can put those together. So it's going to be 14x, and then the negative 12 comes in. On the right-hand side, I still need to multiply the 4 through the parentheses. So I need to use the distributive property there. So 4 times 6x is going to be 24x. 4 times negative 5 is going to be negative 20. And then the parentheses are removed, and this leaves us with this adding 6 out here. So at this point, the left side is simplified. This 14x, I should say, minus 12. But on the right-hand side, notice how you can actually add the negative 20 and the 6. That's going to give me a negative 14. So that's going to give me 24x minus 14. So we have simplified each side of the equation. I do need a 24x there. Got to watch out for things like that. So yeah, that comes down. That looks correct. I do want to pick on the little guy at this point, since the variable is on both sides of the equation. So that's the 14x. So I want to zero out the 14x by subtracting a 14x, or adding a negative 14x, if you will. So I put a negative 14x on both sides. That's the property of equality. So in doing so, the only thing left over here is the negative 12, because this zeroed out. 24 and a negative 14 is going to give me a 10x, and then you would drop down a 14. So the next step is, I like to have it rewritten as 10x minus 14 is equal to negative 12. So again, I want to get x by itself. So I want to get rid of the constant first, which is the negative 14. So I use a zero pair there to add a 14 to both sides. So the negative 14 and the 14 will zero out. So 10x and a negative 12 plus a 14 is 2. So again, a 10x there. I'm sorry. That didn't look very good. Try to clean that up a little bit. So I have 10x equals then negative 12 plus 14 would be a positive 2. So this one looks a little weird. 10 times what number would be 2? So it's going to be a kind of a what we call a fraction or a decimal answer. So to make the coefficient disappear, we can divide both sides by 10. So the coefficient is going to drop out of the problem. So I'll come across this way. So x is going to equal this 2/10. Now notice that this is a fraction, but we need to reduce it, simplify it. So that would turn down into 1/5. So as a fraction, that would be 1/5. Now, if you look at my lab, if it accepts fractions, you can just leave it as a fraction. But if you need to change to decimal, you can go ahead and just divide 1 by 5. Well, 5 doesn't go into 1, so I add a decimal, add a 0. 5 goes into 10 twice, so there's a 10, remainder is 0. So that means it's 2/10. Well, there it is right there, 2/10. So you could write the answer as 1/5 or 2/10, depending on if my lab has any restrictions on it. Pay attention to the restrictions. Otherwise, either one of those answers would be acceptable. 1/5 or 2/10 would be the correct solution. So if we look at this next example, what's tricky about this is we have subtraction outside of parentheses. When there's subtraction outside of parentheses, it's actually going to stand for, we're going to actually take the opposite of it, and we're going to actually bring it through the parentheses first. So this 5y is going to come down, but what I want to do is bring this negative through the parentheses, which means the signs will change. So it's going to be a negative 2y, and this negative 10 is going to turn into a positive 10. So in this situation, it's going to actually stand for the opposite of, and that's going to equal then is 25. Notice how we do have like terms here. A 5 and a negative 2y would be a 3y plus 10 is equal to then this 25. So from there, to solve for y, we can lose 10 on both sides, use the 0 pair there, and then simplify that. So we have 3y and 25 lose 10 is 15. So 3 times what is 15? That'd be 5. Or if we divide both sides by 3, y would equal, y would equal 5 if you divide both sides by 3. So the solution to that one would be 5. So the catch there is make sure you bring this negative through the parentheses to remove parentheses, which means the signs inside the parentheses have to change. So that concludes another 3 questions.